Hello viewers, welcome to 𝗵𝗲 Academy, and in this video we are going to discuss about the CUET undergraduate program, and in which the subject paper we are going to discuss is physics, where we are going to talk about electrostatics, the very first topic of the syllabus, that is in the CUET undergraduate physics paper, right? So 𝗵𝗲 Academy welcomes you to this lecture, and this is our contact details. You can contact us, call us for further details regarding the admission and the classes. Okay, so let's begin with our topic, that is electrostatics from the physics CUET undergraduate program. Okay. So if we begin, so the very first thing that comes in mind is electric charges and fields. And the word electrostatics, if we talk about it, so it is basically a branch that deals with the study of forces, fields, potentials that arises from static charges, right? So this is a branch where we are going to see talk about the forces, fields and potentials that arises from the static charges. And if we talk about the electric charge, right, so electric charge historically, if we see, so it was discussed by the ancient Greek people, right? In 600 BC we can see, where amber was rubbed with wool or silk and it attained a certain amount of charge in it. Today also, if we rub glass with a wool, so we will see that the glass will attain a charge, right? And that charge may attract pieces of paper also, right? So simple experiment you must have conducted in schools also, okay? So therefore the name electricity also came from the Greek word that is known as electron, that means amber, right? So this simple experiment gave to the new branch of electricity, right? And today, you know, the modern world works on electricity itself. Okay, so therefore certain things, you know, plastic, glass, if it is rubbed with certain other element material, so it will attain a charge, right? And that will be known as electric charge. From there, if we talk, now we have understood what is a charge. So from there, if we see, so there are two kinds of charges, that is like charges. Like charges will have what? They will have the same polarity, okay? So it means that they are positive charges, so they will repel each other, they will go away from each other, and unlike charges will attract each other, okay? So unlike charges means they have different polarities, maybe positive and negative, and they will attract each other, but positive or negative will repel each other, and therefore the charges are classified. And since we have talked about positive and negative, so therefore the polarity of the charges is also to be defined, which was given by Benjamin Franklin, and therefore the charges are defined as positive and negative, right? So these are the basics of electrostatics, where we have defined about charge, their polarity and their types, that is like charges and unlike charges. Okay, so till here I hope that it is clear to you, and after which we will define conductors and insulators. What are conductors and what are insulators? So if we talk about it, the very first is insulator. Insulator is a material that will not allow electricity to pass through it, right? So that will be a insulator, and where it will include glass, plastic, wood, any material that will not allow electricity to pass through it. So you can see the photographs also, that is rubber and glass, plastic. Next is conductors, which is quite opposite, where the electricity will be passed through that material. That material will allow electricity to pass through it. If it does not allow, so it means that it is offering resistance, right? So that is known as resistance. So it means that insulators will have very high amount of resistance and conductors will have very less amount of resistance. Okay, so where like metals, earth, other like copper, you can see aluminium, okay, human body is also a conductor of electricity. In between it comes, that is semiconductors. Semiconductors means that in certain conditions they will allow electricity to pass through it. They will allow electricity to pass through it, and therefore modern electronics like diodes and chips, electronic chips, they work on certain principles, right? So semiconductors are in between insulators and conductors, where in certain conditions they will allow electricity to pass through it. Okay, so these are the classification of materials as conductors, insulators and semiconductors that we have seen. Now if we move ahead, so now we'll talk about the very first law, or the very basic law of electricity or electrostatics, that is the Coulomb's law that you must have studied in school. So we'll just have a go through in it, where the Coulomb's law states that if there are 2-point charges q1 and q2, there are 2-point charges, okay, q1 and q2, that may be like charges, that is positive positive, unlike charges also. If they are like charges, so they will have what? Repulsion, the forces are going away. If they are unlike charges, they will have attraction. Okay, so this is what, so it may be repulsion or attraction, that does not matter, but here what will be there? If they are separated by a distance r, so then the force, that this force, that is repulsive force or attractive force, that is acting upon them, can be defined by this equation, that is known as the product of the charges and the inversely proportional to the square of the distance between them. Okay, so this force is proportional directly to the product of the charges and inversely proportional to the square of the distance between them, along with the constant, because we will have a equal sign. So that is constant is 1/4 epsilon naught, that is 9 into 10⁹ Newton meter per Coulomb square. Okay, and epsilon naught is known as permittivity of free space, and its value is 8.854 into 10⁻⁻12 Coulomb square per Newton per meter square. So this is the main equation that is going to define the force by any 2-point charges. Okay, that is q1 q2 divided by r square. Fine. So this is the very first and the basic law of electrostatics that we are going to so here also we can see it is measured in Coulomb again, yes, it is measured in Coulomb. There is a force between 2-point charges found that is varied inversely as a square of the distance between the charges and was directly proportional to the product of the magnitude of the 2 charges acted along the line joining the 2 charges, right? So here again it is given that if the 2-point charges q1 q2 are separated by a distance r that we can see, then the magnitude of the force between them is given by this equation, that is F is equal to 1/4 pi epsilon naught q1 q2 divided by r square. Okay, so this is the basic equation of, and the very first law, that is the Coulomb's law. Very important, asked in the examination also, but it has another form also, that is the vector form. So when we talk about the vector form, now we have to give the direction, because in this very first law that we have seen, so here we were talking about the force that is in the alignment, right, along the line joining. Here you can see along the line joining the 2 charges. So along the line joining the 2 charges we are seeing the force, but in the vector form if we see, so in the vector form it is not along the line joining, it is away from the line joining the 2 charges. So therefore in such a case we have to see what is the force upon this point. Okay, so now the things become complicated. So now we have to use vector analysis, in which we will give the direction also on the force. So the very first direction that we are going to give is this likewise. Okay, where if we talk about suppose like this, the vector leading from 1 to 2, the vector that is leading from point 1 to point 2 will be given as r21. R21, that is point 1 to point 2, point 1 to point 2, and the force also will be given as F21. It means that it is the force that is exerted by charge 1 upon the charge 2. Okay, so this is what is given in this thing. So you have to give the direction also, right? So F21 is what? F21 is the force that is exerted by charge 2 upon the charge 1. And finally with this resultant we have to see what is the force that is in the point O. So similarly you can see that the vector leading from 2 to 1 is known as R21, that is R1 minus R2. And finally the Coulomb's law between 2-point charges in the vector form can be defined as 2 forces. Now there are 2 forces F12, that is 1/4 epsilon naught, and now here a new vector will come, that is known as the unit vector, because here we are taking the magnitudes, that is q1 q2 ka magnitude and r12 ka whole square. Okay, r12 means again the same thing, r12 means that is from 2 to 1. Okay, here this r 2 to 1. The opposite also F21 will be 1 by 4 pi epsilon naught q1 q2 divided by r21 ka whole square and the unit vector r21. So these two forces will be calculated and the resultant force will be given, and that will be known as the final force. Okay. So finally we can see this, that the Coulomb's law, it's similar to the Newton's third law. Okay, so it replicates, or you can say it exactly imitates the Newton's third law in the physical form in the electrostatics. Okay, so this is the Coulomb's law in the vector form. Alright, so hope that you have understood this. Now since we are talking about force, till now we are talking about the force between 2 point charges, because there are two different points and they are exerting force upon each other. Now what if there is one single charge? Okay, so therefore if we talk about one single charge, then the effect of the single charge on the surrounding area will be known as the field, and that will be known as electric field. So here we have already talked about it. There are two kinds of polarity, that is the positive polarity, negative polarity. If it is a positive polarity, the field lines will go out of the charge. If it is a negative polarity, the field lines will go inside the charge. These are the field lines. Okay. If again they are of opposite polarity, so they will have attraction. So the field lines will go from positive to negative. Right. So this will be the situation, and if they are of same charge, so it will have repulsion, so the field lines will go away from the field. Okay, clear? So these are the conditions. Apart from that, if we see, so now we will see that what is the effect of a point charge, that is q. We will take a positive charge, and suppose if I come here, if I take a point that is near the charge, right? So now we will see that what is the effect of this point charge upon this point, and this distance will be known as r. So here you can see a charge q produces an electric field everywhere, okay, because it is a 3D space in the surrounding. When another charge is brought to some point p, in certain point p, if another charge is brought, then the field acts and produces a force, and this electric field produced by the charge q at point r is given as this equation, that is electric field E at point r, constant 1 by 4 epsilon naught, the point charge q divided by r, the distance r square, and the unit vector, because now we have to give the direction also. So electric field is always given in direction. Okay, so unit vector, that is r. Okay, so it means that the field is showing what? It is showing the distributed quantity of the that force, that the charge is existing in the 3D. This force is also can be calculated by the Coulomb's law again, because here we have brought a test charge, that is q, right? The main charge, that is capital Q. So now the force according to the Coulomb's law, it will be what? The constant 1 by 4 epsilon naught, and the main charge and the test charge, capital Q and small q, the product of it, and the square of the distance, that is r square, and the unit vector, because you have to give the direction. Okay, so now this will be the force that is acting upon the direction. Okay, clear? So this is the field and this is the force. So Coulomb's law and electric field both are parallelly given here. All right, I hope that is understood to you. Okay, okay, then if it is understood, so we can discuss one question about it. So this question we can see two charged particles, right? Q1 and Q2, two charged particles are there, are placed as a distance d apart. Now this is not r, it is given as d. So Q1, Q2 and d, that is the distance given from the vacuum, exerting a force F. The force is F itself, and now each charge is doubled. Now each charge is what? It is doubled. To keep the force unchanged, the distance between the charges should be changed, right? If the force is to be same itself, since the charges are doubled, so it should be similar as the original force. So now what would be the distance or change in distance that is required? And these are the options: 4d, 2d, only d, or d by 2. Okay, so you have to calculate it. The original force, that is F, is equal to constant plus constant multiplied by q1 q2 divided by r square, but now q1 q2 is 2 times, right? So here you will have 4 times. So therefore similarly you have to solve the equation and find out the answer. So I have given you the hint itself, right? Try to solve it out. It's a very simple question that I have given to you. Try it out and answer it out in the comment section, right? Okay, so definitely the right answers will be given certain symbols. Okay, so it will be known that this is your correct answer. So try it out, solve it out and answer it in the comment section. Okay, so with this I will conclude today's topic or today's video that I have brought it for you. So again, Bhadra Academy thanks you for watching the video thoroughly, understanding the topics and being with us. Again the same you have the contact number here, it's given in the screen, you can see, and you can contact us for further details regarding the course, the fees and the duration and other things. Okay, so definitely we are there to help you out in the examination process. So be with us, give us a chance to serve you better. Thank you so much.